Welcome, viewers, to the Daily Space Weather Show. I'm your host, Dan, aka Smash-O-Mash, and we've got a little bit of an increased solar wind parameter going on here. So the likelihood of aurora at high latitudes has gone up quite a bit. So just some little changes going on there with the solar wind. We'll talk about it. These are the past 24 hours from the closest star, 171 angstroms from Solar Dynamics Observatory, the house favorite. And by the way, thanks for tuning into the Smash News Network, least busted name of news. Don't forget to press the like button, subscribe if you're new, etc. And let's do a famous quote, shall we? This one from Groucho Marx. Outside of a book, a dog is man's best friend. Inside of a dog, it's too dark to read. The 10.7 centimeter radial flux is now at 181 solar flux units. Yeah, 181 is the radial flux number. There's the past year. And we do have a possibility of a big uptick in sunspot number here. So if we see some growth in the east, and there is a possibility of that with what we see in terms of the magnetic fields in the heliosphere, we may indeed see sunspot number here come way back up to and possibly above 200 sunspots. If you check the Space Weather Enthusiast dashboard, you might notice a little bit of geomagnetic unrest, or a mild geomagnetic storm is forecasted by ESA and NOAA for Friday night into Saturday morning. So that might give some of you mid-latitude aurora chasers a little bit more of a chance to catch some aurora. And you'll probably see some very spectacular aurora if you are at high latitudes. There is NOAA's Enlil spiral. Again, expecting it to arrive late in the day tomorrow and finish up early in the day on Saturday morning. Here is ESA's Enlil spiral, and they're expecting some fireworks there. They're expecting the solar wind density here to get up to like 90 protons per cubic centimeter. I think that's a bit of a gracious forecast. I don't even know if a CME is going to strike. In fact, if you watched our video from the 24th, you would notice that I don't really think those are earthly directed. But we'll see what happens. Next, the last 4 hours of Earth's magnetic moment from space. It's our Geospace Magnetosphere movie. And like I said, we do have a little bit of an uptick here in things like solar wind density and some magnetic fields that are more conducive to inducting current into the Earth system. So that's good news for aurora chasers, right? So that's our Geospace Magnetosphere movie. A little bit of an uptick there. And you'll see that reflected in the ground magnetic perturbations map as well. Earth's magnetic moment from the ground there for the past 4 hours. Our ground magnetic perturbations. This depicts geospace delta B, which would be changes to Earth's B field in magnetic flux density, which would be nanotesla, are the units. Next, KP index at 2.33, and if we see some stronger fields, we may see that rise up to geomagnetic unrest rather rapidly. Again, we are seeing the possibility of that. Now, yesterday's Daily Space Weather video, we talked about the possibility that there may be a coronal hole high-speed stream showing up, and it doesn't look like that's really what happened. If so, it was an extremely weak one. Since then, we've just had some increased solar wind parameters here because of some, denser solar wind outflow. So some stronger magnetic fields here. We saw, let's see, a BT of 11 with a BZ of -8. That's pretty good. If we see that sustain, which we haven't, but if we do see a field like that sustain with those parameters, that might be more likely to produce some geomagnetic unrest conditions. So those are the data from the ACE. Here's a Discover, much denser there, nearly 20 protons per cubic centimeter. But the field is not that strongly negative. So again, if we see that top line there, the top line is the BTBZ. The white line reflects the total magnetic field at Lagrangian point 1, and the red line reflects the vertical component. So when you see negative BZ, that's a southward oriented magnetic field. Positive BZ is a northward oriented magnetic field. So yeah, increased solar wind outflow here. 19.5 protons per cubic centimeter for the density. But the velocity remains slow here at only 328 kilometers per second. So quite slow, but a lot denser than normal there for the solar wind. Next is our GOES magnetometer. Actually, make it two, the GOES 16 and the GOES 18. They are measuring the magnetic fields in the Earth's outer Van Allen belts. They orbit in a geosynchronous fashion at about 23,500 miles of altitude. So no major action going on there as measured by the GOES magnetometers. Next, the heliosphere magnetism. So now, do we still see turbulence over here to the east of Earth? Well, it looks like things have calmed down and the North Pole magnetic sector has won that magnetic battle. So expect to see continued rising of North Pole-oriented coronal holes, but don't rule out the possibility of more sunspots forming there in the east. Next, our line of sight field plot. And you might notice that the B field, which are the blue potential field surface source lines, they're waving around quite a bit there to the east, which would be your screen left. But since then, they have somewhat consolidated with North Pole magnetism. But keep in mind, the magnetic environment can change with essentially no warning. Could be more conducive to producing a lot of sunspots in the east, in which case we may see a big rise in the sunspot number in the coming days. Next is our line of sight coronal hole plot. That's what's going on with coronal holes. And let's cut to the SDO once that plays through one more time. North Pole coronal holes will be the main story here. And there is the SDO 211 angstroms wavelength. You may see some fairly weak-looking coronal holes here rotating in the east. Those will get a little bit more well-defined in the coming days, I suspect, as we peer down into the bumpy corona. Next, sunspots. Sunspot number here has dipped only a little bit, though. Still about 171 sunspots, 171, 172, something like that. And we have a high possibility of large solar flares down there in the southeast. So sunspot 3728 and or I think it's 3728. But we'll show you close-ups of the magnetic fields toward the end of the video. So at the moment, we do have a significant possibility of large flares down there in the southeast, as high as over 50% for an X flare for the past 24 hours. So that's pretty good for all of you wishing for additional space weather, as we are. So there's our potential field surface source lines map along with named sunspots, the SDO magnetogram. And how about sunspots? There we go. So that's what about 170 sunspots looks like. And we'll also show the animated magnetogram here. There you go. Actually, let me cut back to the continuum here for a minute. No major changes going on there, so no big-time evolution. Those sunspots are largely stable. Over the past 24 hours, the time period depicted there at 30 frames per second. So there's the magnetogram. Again, lower left is a portion of the closest star to keep an eye on. And when I say eye on, well, the pun was intentional. All right, so moving right along here, we're going to get to solar flares and energetic particles next. The GOES proton flux remains at baseline levels, and the likelihood of seeing a spike in the proton flux is kind of low. As far as the flare output's been kind of low as well. Is it the calm before the solar flare? Well, perhaps. Background flux is all the way down to about a C1.3. So pretty weak levels of activity considering we see 170 plus sunspots right now in the Earth-facing portion of the disk. And there is our 131 angstroms wavelength. Based on looking at that imagery, it looks like the most active sunspot for the past 24 is actually that equatorial group that just rose there in the east, right on the equator, which I believe in yesterday's daily space weather video, I said that was the most likely place to see a large flare. It's been the most active in the past 24 hours. Now, for those of you who were not aware of this already, solar flares are predictable by using the magnetic shear. When you have strong magnetic field-based umbrae that are of opposite polarity, very close to each other, that is the recipe for large solar flare activity. Next, solar system forecast. We like to show people where things are before we show coronal mass ejections. So here's where things are today as we get heliographically oriented. This is what's going on in the heliosphere, or solar system, if you prefer. And that is where things will be in 1 week, on Independence Day. Next is a star chart. We always like to know what's going on overhead. So I show a star chart for our local area. That's skyandtelescope.org if you want to create your own, skyandtelescope.org. And before we get to CMEs, a brief look at the Serpens Nebula. Now, what's great about this is that this resolves previously blurrier images. So that's from the James Webb Space Telescope, as you may not be surprised based on the way that imagery looks. And what's interesting about this is that the polar jet outflows from those stars appear to be largely oriented in the same directions. So now, these are active stars, as they have, active stellar jets coming out of their poles. And those jets are going to be perpendicular to the equatorial plane. So if you imagine the sun blasting out jets from the poles, you live on the equatorial plane. And so that's the Serpens Nebula, another great series of images there from James Webb Space Telescope. Moving on to CMEs. And it's been really kind of low levels of activity here for the past 24. Now, there are some missing frames there. I think we may resolve some of those with our custom coronagraphs, but let's see. There is LASCO C2 and C3 together, and there's a little bit of a lapse there. Stereo A. Stereo A is missing several hours as well. Let's just move to our custom coronagraphs. Just minor activity here in the past 24. So, is it the calm before the solar storm has kicked off? Let us know in the comments what you think about it. That's another 24-hour video. And let's move to the little closer view here, and we've added the 193 angstrom 60-minute running difference there to help show filamentary motions. It does not appear to me that there are any additional coronal mass ejections headed in Earth's direction here. Again, the activity has been pretty minor. Well, that's my story, and I'm sticking to it. So, what's next? Filaments. We've still got a lot of them, and some very large ones. By the way, one of them is growing unstable. So if you look sort of right in the center of the disk, let me put an arrow. There you go. See that arrow right there? Let me move it. Right there. That filament right there has become unstable in the past 4 hours. It may eject, in which case there is a strong possibility that we'll have an Earth-directed CME. Fingers crossed for that. That's Big Bear. Big Bear, California's hydrogen alpha ground-based telescope. And let's blast through bonus features, but first, the past couple of hours. And check out that filament right in there. It is a lot less stable than it was yesterday. That's the past couple of hours from the GO 16 SUVI. Like 2.5 hours. Some crown prominences at both poles. That's always nice to see. And expect to see a lot more of that in the coming 8 months. That's about the time from now to solar maximum and back down to where we are now. Not quite at solar maximum. Bonus features are next. Charging hazards. We have some minor surface charging there over southern Asia. The GOES electron flux here is kind of low. And again, there have been some outflows striking the magnetosphere, so that's there is a little bit of action for space weather today, which typically causes erroneous readings in the electron flux. There's the forecast model, and NOAA's expecting a big downtick when that CME impact that NOAA and ESA have forecasted are forecasted to impact. So no disagreement there. Next, the ionosphere. Feel free to pause the video on this frame if you're not familiar with the atmospheric layers, the penetration of electromagnetic radiation and chemical concentrations in said atmospheric layers. Here's the F layer of the ionosphere. Did you know that Earth's atmosphere extends out well beyond the moon? Yeah, pretty crazy, right? The exosphere. So that's what's going on at the F layer. That's at about 300 kilometers of altitude. That is the vibrational frequency in megahertz, millions of vibrations per second. Diffuse gas. It can vibrate very quickly. And of course, the fastest vibrations are around the equator at noontime. Here's the anomalogram, anomaly in megahertz from a 30-day median. South Atlantic anomaly still stationed on the coast of South America, right on that 40-degree west longitude line. So if you want some reason to stay in your bunker, maybe that's your reason. Next we'll show the WHAM, Wake Me Up Before You Show the Global Ionosphere Nowcast. Especially if you want to know where the GPS errors will be located. Quite a bit of GPS errors likely there over the Pacific. High-res images of the closest star. And what do you got? It's Beta Gamma class. I'm not so sure if it's Beta Gamma Delta class. Certainly Beta Gamma class. And as far as these other groups go, those are pretty good. Well, Beta Gamma class, once again, I don't think the likelihood of large flares is that high. I think things are looking pretty calm. And we'll close out with some more images of filaments. Because, well, we've got some good ones, including an unstable one. So fingers crossed that that will eject. Again, that unstable filament is just southwest, which would be down and to the right from sunspot 3723. So that's what's going on. Thanks for tuning in to the Daily Space Weather Show. Except no wooden nickels, folks. Except no wooden nickels. Anyway, I've been your host, Dan, a.k.a. Smash-O-Mash, and it's been a pleasure. In the meantime, until next time, may that solar wind be at your back.